Hello everyone, welcome back to another episode of Solving LeetCode Hard Question. Today's question is wildcard matching. The question is as follows. Given an input string S and a pattern P, implement a wildcard pattern matching with support for question mark and star sign, where the question mark matches any single character, and the star sign matches any sequence of characters, including the empty sequence. The matching should cover the entire input string, not partial. So let's look at a few examples here. The first example, we have the input string as AA and the pattern is the star sign. Since the star matches any number of characters, this is a match and the output is true. Let's look at another example. The input is CB and the pattern is question mark A. Question mark matches any single character, so C is good. However, B is not equal to A. Therefore, there is no match here and the output is false. We also have the constraint that the length of S and P are greater than or equal to 0 or less than or equal to 2000. And S contains only lowercase English letters and P contains only lowercase English letters plus question mark and star. How do we solve this? Pause here for a moment if you like to think independently first. So the key hint to this problem is that the star sign matches any sequence of characters including the empty sequence. So it might be beneficial to cache the previous matching results and use that to build our next result. This leads to our general approach, which is a 2D dynamic programming problem. And the idea is that using the previous matching result, we can determine if the next character in the string matches the next character in the pattern. Let's start building our 2D dynamic programming table. Here I've created a DP table with S being A, B, C, M, N, P, and P being A question mark C star B. I've also created an empty slot at the front to account for when S and P are empty. Here we want dpij to represent if S all the way to index I and P all the way to index j are a match. So let's look at this block. We're essentially trying to determine if AB matches A question mark C. And the answer is no, but we'll have to build it from the previous results. To start, let's build the first row of the table. An empty string matches the empty string, so dp at index 0, 0 will always be true. However, afterwards, S remains empty, which means P has to contain only stars. In this case, P has an A, so this is false, and the rest of the cells will also be false. Next, let's build the first column. This is easy because when P is empty, S cannot contain any characters, so the rest are all false. Now we can actually start building the table by iterating through each cell. First, the character A in S matches the character A in P, so we know that the addition of the character A is a match. If the previous result is a match, then we know that with the addition of the character A, the new sequence is also a match. Moving on to the next cell, question mark should have matched the character A because question mark matches any single character. However, if we look at the previous result, the empty string S does not match the pattern A, and that's why the new sequence will still be false. Then in the next cell, C does not match A, so immediately we know that this is false. Here we've essentially identified three cases. Case 1 is when the character in S matches the character in P. Then we look at the previous result to determine the new sequence match. Case 2 is when the character in P is a question mark. Then we know that question mark matches any character in S, so we also look at the previous result at index I-1, j-1. Case 3 is when the character in P does not match the character in S. In this case, we immediately return false. This leaves us with the final case to solve, which is when the character in P is the star. We'll look at it closely at the next slide. The answer is we will look at dp at I minus 1 j and dp at I j minus 1. And if either of them is true, we return true. Why? Let's look at two examples. In the first example, dp at I minus 1 j is when p is a question mark c star, and s is ab. This is not a match. For dp at I j minus 1, p is a question mark c, and s is abc. And this is a match, and therefore dp at ij is a match. So really, dp at ij minus 1 represents the case when the star would be considered an empty character. So when a new character is added, it does not account for anything, and the new sequence will still be a match. Let's look at the next example here. In this example, dp at I minus 1 j is when p is equal to a question mark c star and s is abc. And that is a match as we previously calculated. And for dp at ij minus 1 is when p equals to a question mark c and s is a b c m. And that is not a match. However, since dp at I minus 1 j is true, the overall result is true. So really what we're looking at for dp at I minus 1 j is when the star was already previously considered. And adding a new character is still valid since the star matches 0 or any number of characters. If we keep building a table to the end, we'll arrive at the final result, where the answer is false. So now that we have all the cases covered, let's put this into code. This is a Python code for the solution. First, we initialize a dp table with all false entries. As discussed, the first entry where both p and s are empty strings is true. Then for the top row, it is a valid match as long as the character in p is a star. Once it's no longer a star, the rest of the values are false. The entries in the first column are already false, so we don't have to do anything. Moving on, we'll set dp for the rest of the rows. Here, we'll cover the 4 cases we just discussed. Case 1 and 2 is when the new character in p and s match, or when the character in p is a question mark. Then we simply look at the previous result at index I minus 1, j minus 1. For the 4th case, when the character in p is a star, we look at dp at I minus 1 j or dp at I j minus 1. Again, just to reiterate, dp at I minus 1 j is the previous result when the star was included, and dp at I j minus 1 is when the new character star will be counted as empty. Finally, we return the last element in the dp table. The final time complexity is O of m times n because we iterate through each element in the table. And the final space complexity is also O(m) times n, m being the length of s and n being the length of p. That was a really solid solution, but can we make any improvements? For example, can we reduce the space complexity from O of mn to O of n? If we look at the dp table, what we really need is the previous row for us to build the current row. So instead of storing the table, we could just store the previous row and the current row to reduce the space complexity to a single row. Can you implement this? Let me know your solutions in the comments. And as always, thanks for watching and see you next time.